everyone. In this video, we're going to talk about linear inequalities. We've been talking about solving an equation with one variable and some word problems that go along with that. So before we leave this chapter, we're going to throw in inequalities as well. So an inequality is a less than or greater than, less than or equal to, or greater than or equal to. And for the most part, we're going to solve them in the same way as we would an equation, but there are a couple of major differences. All right, so the first major difference is that instead of getting one number as our solution, we're going to get a whole set of numbers. And so because we get a set of numbers, we need to represent the answer in a little bit different way. And we've talked about these kind of throughout the semester, so we'll take some time to talk about them one more time here. So since this is a set of numbers, a group of numbers, right, usually the answer is not in such a way that we could list out these numbers. And so we need to use either set builder notation or interval notation. So I'm going to take a minute just to review real quick what interval notation is and how it works. So if you haven't gathered that up till this point, this would be a really great time to tackle that. This is definitely something that we talk about in college algebra. I usually start the semester with interval notation and then we use it a lot. So it'd be good to kind of get to know how to use it. When we use interval notation, again, we're going to be describing a set of numbers, and we want to list the endpoints from left to right separated by a comma. And then around those endpoint numbers, we're going to use either the round bracket, well, I usually say round parentheses, or square bracket. So I'm going to use the round parentheses if I don't have the equals bar. So if the endpoint is not included, and we'll see a couple examples of that. So if the endpoint is not included, then I'm going to use the round parentheses. If the endpoint is included, so the number on the end is also a solution, then we're going to use the square bracket. All right, so let's just give you a couple of examples. I like to use a number line to draw this out. I think it makes a really good visual aid. It is important to mention that the number line is not the solution. The interval notation that we're going to write below it is the actual answer. So drawing the number line is good, but it is not the answer. It's just helping you to get to the answer. Okay, so this one says we want to represent all the numbers that are less than or equal to -3. So this is just for your scratch work, so it doesn't have to be a perfect number line. So I'm less than or equal to, so I use the closed-in dot to show that the -3 is included, and then everything less, smaller than -3 would be to the left. And if I shade the arrows represent the infinities, right? So this goes all the way to -infinity. The infinities, because they're not an actual number, always get the round parentheses. So I would go from left to right, so from -infinity up to -3. And because I colored in the circle here, I did the closed circle. Or you could put the bracket right on the number line if you like that better. I did it because I have the equals bar and this number is included. So I want to use the square bracket. Okay, how about x's or numbers that are greater than -2? So here's -2 on our number line. This time we do not have the equals bar, which means we're talking about numbers that are bigger than -2, but not equal. So we're going to get infinitely close to the number -2. So we always have to think really hard about this. So this would be -1. So -1.999999999 would be included, but not 2. Okay, that's what that open circle represents. So because it's an open circle, or again, you could put the parentheses right on the number line if you want, but I'm going to use the round parentheses, and I'm going to list the ends from left to right. So from -2 to infinity is kind of where I've shaded, and that's where all these numbers would be indicated. All right, then we can get to some interesting ones. So if I have more than one inequality, there may be a word in between. So if the word in between is and, then that means that these two inequalities can be satisfied at the same time. And if they're satisfied at the same time, we actually could write them together as what's called a compound inequality. I call it a double inequality, so either of those words work. So let's draw the picture, and then I think you'll understand this way of writing it. So here's 2, 3, 4, 5, 6. Okay, so in this example, I want x values that are less than or equal to 6. So 6 is included. And I'm going to start shading to the left because that would be numbers that are smaller. And at the same time, numbers that are also greater than or equal to 2. So I'm going to, could be equal to, so colored in dot, bigger than 2. So both bigger than 2 and smaller than 6 kind of gives us this in-between kind of phenomenon, right? So all the numbers in this region, like 3, 4, 5, or any of the decimals in between, are both less than or equal to 6 and greater than or equal to 2. And so because it's one section of the number line, we can write it kind of in this in-between sort of way. But the interval notation is going to go from left to right. Notice we have 2 closed-in dots there, so I'm going to use 2 square brackets. This next example is an or. So usually if the word or is used, we're going to get 2 separate pieces of the number line. And so a number might be in this group, or it might be in this group, but not in both usually. Okay, so if we label our number line, I want x values or numbers that are less than or equal to -1. You have the equals bar there, so I'm going to use the closed dot. Less than, so it's going to go all the way to -infinity. Or I want numbers that are greater than 6. There's no equals bar, so I'm going to use the open dot and greater than. Notice these don't overlap. They don't meet in the middle. They're 2 separate sections. The way we write them in interval notation is just to write each piece separately. So the first piece goes from -infinity up to -1. -1 is included, so that's square bracket. And then for the second piece, we have the open circle there, so round parentheses from 6 up to infinity. If we have more than one piece, we connect them with what's called a union. So it just sort of looks like a U. But it is really a mathematical symbol that means I'm going to take the numbers in this group and the numbers in this group and put them into one big group. All right, so that's all of the details about interval notation. So now let's apply that and solve an inequality. So like we said, you can solve this just like an equation. The 2 big differences are our answer is a set of numbers, which we just addressed. And then number 2 here is the other big difference, and that is if I multiply or divide by a negative number, I'm going to flip or reverse the inequality. So if it was a less than, it becomes a greater than, and vice versa. Okay, so let's try this one out. So I want to solve here. Maybe a good first step would be to distribute this negative. Think of it like a -1 out front. So we're going to have 1 minus 2/3 x minus 2 is greater than 5. We want to move all these numbers over to the other side. Maybe we could combine them first. Let's do that. So negative 2/3 x, this is a positive 1 and a -2. So if I add them, it's going to add to be -1. And then let's move that over. It's greater than 6. Okay, and then we would rather just have x on this side, so we're going to divide both sides by -2/3. Okay, and some important things are going to happen, right? First of all, we're dividing by something that's negative, so we are going to flip. Instead of a greater than, we are going to have a less than now. Also, we are dividing by a fraction. So to divide with fractions, we're going to do that keep, change, flip. Okay, and then we'll talk about some of your other options. So I'm going to keep the first number. I'm going to change this division to multiplication, and I'm going to flip this over. Okay, and if you need to, you can think of this as 6/1. So you could reduce first or multiply and then reduce. 6 times 3 would be 18, and then we're going to divide that by -2. So we're going to end up with -9. Okay, we got one more step, but let me just talk through some other options, right? This time, for whatever reason, I decided to divide by the fraction, but you could also have multiplied by the reciprocal. So you could have multiplied by 3/2. They would have canceled on this side, and you would have done the same sort of arithmetic to get your -9 on the right side. Okay, the last step for these is to write your answer with interval notation. So the number line is optional. If you need it to give you a good picture, you're welcome to do that. I want numbers that are smaller than -9. So my final answer, I'm going to go from -infinity up to -9, and I just have a less than, not an equal to, so I'm at the round parentheses for that. All right, so that's the basic idea. I think I have one or two more for us to try. Okay, so this is a compound inequality or a double inequality because we have two inequality symbols. And you have two options to solve this. I like to solve it like a three-sided equation. So I do everything to all three sides. And that's easier for me. Okay, so I'm going to work it out that way. Your other option would be to do it one inequality at a time. So you could solve the inequality on the left, which looks like this. And then separately, you could solve the inequality on the right, which looks like that. Okay, so you could divide it up into two parts if you prefer, and then kind of reassemble your solution at the end. It's going to involve the same operations that we're going to do together, so you can choose which method you prefer. Okay, I'm going to solve it like a three-sided equation, which means I'm going to do everything to all three sides. So when I do that, I need to get the variable by itself in the middle. I don't want to move the variable to the right or to the left. There's no good reason to do that. I want to keep it in the middle. This is going to be one of those in-between type statements. And so I want to know what numbers the variable is in between. Okay, so my first step in isolating m is to subtract 5 from all three sides. My next step is to remove this negative 1/3. And you can do it by dividing all three parts by negative 1/3. Or we could do it by multiplying by the reciprocal. I think I'll do it that way this time. So the reciprocal, if I were to flip over negative 1/3, I would get negative 3. So I'm going to multiply the left, the middle, and the right by negative 3. In the middle, that's going to cancel, right? And I'm going to just be left with m. On the left, it's going to give me 21. And on the right, it's going to give me 9. Now, just like in the last problem, remember if I multiply or divide by a negative, I have to flip. That works for this method too. So we have to flip both of the inequality symbols. Okay, and so we're left with this result. M is in between 9 and 21. Now notice that when we started, this was written from smallest up to largest, right? But in the process of solving, because we had to do a flip, now it's organized from largest down to smallest. So if you would rather have it smallest to largest, you can just form a mirror image of what you see here, and that's still going to be a true statement. So let me just jot that down below in case you want to have that. So 9 is the smallest. So this is the same as. Okay, and bigger than 9 is m. And then bigger than m is 21. So I have struggled with this a little bit when I was learning it. So I always make sure that the inequality symbols are still pointing at the same numbers. So right now it's pointing at the 9. So when I flip it around, it should still be pointing at the 9. I don't really want to change anything. I just want to make it look neater for me so that it reads better from smallest to largest. And same thing here. This one's pointing at the m, so it should still be pointing at the m. Then we want to write this in interval notation. Now that I've flipped it around, it's going to match up directly with the number line. Notice that I want numbers that are bigger but not equal to 9. And numbers that are less than or equal to 21. So like I said, this is one of those in between. So my final solution here, we're going to have the parentheses from 9 to 21 and then the bracket. All right, let's try one more. So that compound inequality was an and this one is an or. And so the two-part method that we mentioned for the last one is kind of what we're going to be doing with this one. So we're going to solve these individually and then put them back together for our final answer. Okay, so take a minute, solve these. If you do divide by a negative, which I'm doing right now, don't forget to flip your signs. Okay, so you should get two separate inequalities. If it's an OR, these are not likely to overlap. So we'll draw the picture just to kind of confirm that. So from the first part, I got x is less than -1, not equal to, so I got an open circle. And to the left, for the second part, I got x values that are greater than or equal to 4. So I'm going to do the closed in dot. Okay, so yes, indeed, they are two separate pieces. So I'm going to write each piece with interval notation from left to right. So I'm going from -infinity up to -1, parentheses there, and then a bracket for the 4 up to infinity. Since I have more than one piece, I'm going to join them together with that union in the middle. Now, if you didn't have the union, I would not count that off, right? But it is kind of part of our answer. All right, I hope this gave you a good idea about inequalities, how they work, how to solve with an inequality. So I hope you'll take some time to practice, make sure you got this good understanding. All right, good luck. We'll see you in the next video.